Hello dear students, welcome to Sankalp Learning. So in the last class, we have started with the aldehyde, ketones and carboxylic acid. Okay. We have completed MCQs, right? In the last class, we have completed MCQs. In today's session, we are going to see the 2-mark question. Okay, 2-mark question. And the total marks allotted for this particular chapter, aldehyde, ketones and carboxylic acid is 14 marks. Okay. So for out of 14 marks, 1 mark 2 MCQs will be asked, 2 mark 1 question and 5 mark 2 question. So as you know, in chemistry, directly 5 mark question is not asked. So it can be divided again as 2 plus 2 plus 1, or it can be asked as 3 plus 2. Okay, fine. So in the last class, we have completed MCQs. So today, let us start with the 2 marks question. Okay, so we are going to start with the 2 mark question. So yes. So first, so here are some of the compounds given below. Okay, you have to give their IUPAC nomenclature. Okay, you have to give their IUPAC nomenclature. So like this, any one compound will be asked. Okay, so these are the questions taken from the previously asked question paper. Okay, so most repeatedly asked questions have been taken. Okay, so this will help you to score well in your upcoming board examination. Fine. So let us start. So these are some compounds. So any compound they may ask you, they may give you any structure, and each structure, the name, IUPAC name, if you give correct answer, it will be, you'll be getting 1 mark. Okay. Fine. So first compound is CH3CHO. Okay, CH3CHO. So first is count the number of carbon atom. How many carbon atoms are there? 2. So when you have a number of carbon atoms 2, then it will be what? It is ethane, right? It is ethane, and you have CHO, right? CHO. So CHO, what is the suffix? It is called as al, right? So your E will be replaced by al. So it is ethanol. Okay, it is ethanol. So the first compound is ethanol. So the number of carbon atoms, how many are there? 2. So it is ethane. E will be replaced by al. So it is ethanol. Okay. Next compound, let us go for the next compound, CH3, C double bond O, CH2 and CH3. Count the number of carbon atoms, students. Count the number of carbon atoms. 1, 2, 3, 4. Okay. So 4. Okay. So now how much it is? Butane, right? So butane. Now what it is a ketone, right? It is a ketone. So here you can see, okay, either side of the carbonyl group, you have the alkyl groups, right? So it is, so your, whenever you have ketones, okay, it is represented as ONE, own. Okay, so your E will be replaced by what? ONE. Now at 2 position, you have double bond. So it is butane to own. Okay, butane to own, because at second position you have carbonyl. So it is butane to own. Understood? I hope you have got it. Yes? Okay. Let us go for the next compound. CH2 double bond CH, C double bond OH. So again, this is a aldehyde. Okay, aldehyde. So count the number of carbon atoms 1, 2 and 3. So it is prop. Okay, propane, if I call it as propane. Okay, so you have a aldehyde. So at what carbon? So if I count the number of carbon atoms, okay. So 1, 2 and 3. So your this, okay, your double bond should get the least number. So 1, 2 and 3. So pro, okay. Then at 2 position you have double bond. So it is in, okay, pro, pro. So what we are going to write? So probe, okay. Then at second position you have in, okay, and Al. Aldehyde is represented by L. So it is probe to in al. Okay, probe to in al. ENAL. Got it? Okay. Next compound CH3, C double bond O, CH2, CH2, CH3. Yes, number the carbon atoms. So there are 1, 2, 3, 4 and 5. So it is pent, okay, pentane. Then At 2 position, you have one. Right. Again, it is a ketone, so it is pentane 2-one. Okay, pentane 2-one. So like this, any one structure will be asked for 1 mark. Okay. I hope you have got it. Okay, so any compound they will ask you, and they will ask you the IUPAC nomenclature. Okay, each compound, one compound they'll ask you for 1 mark. Okay, fine. Next question, give reasons. So here each question, okay, they may ask you the questions in the form of give reason. So each question here is for 1 mark. Okay, each question is for 1 mark. So there are 5 questions. Okay, each question here is for 1 mark. Okay, got it? So they may ask you the questions in the form of what? Give reason. So first question, acetophenone and benzophenone do not undergo addition reaction with sodium bisulfite. Okay, acetophenone. Okay, acetophenone and your benzophenone. Okay, acetophenone and benzophenone, they do not undergo what? They do not undergo addition reaction with sodium bisulfite. What is the reason? What is the reason? Yes, anybody? Why acetophenone and benzophenone do not undergo addition reaction? Acetophenone and benzophenone. If I show you the structures, okay. So this is the acetophenone. Okay, this is acetophenone, and benzophenone is this. So at least by seeing the structures, now you can tell me why it is. So nucleophilic addition reaction, how it takes place? It will attack the your carbonyl carbon, right? Your nucleophile will attack the carbonyl carbon. Now you can see across this carbonyl group, there are bulkier group present, right? There are bulkier group present. So the reason is due to steric hindrance of bulkier aryl groups. Okay, the reason is due to. So you have to give the reason in a word or a sentence. Okay, you should not stretch it more. So due to steric hindrance of bulky aryl groups. Okay, bulky aryl groups. Got it? Fine. So acetophenone and benzophenone, they do not undergo addition reaction with your sodium bisulfite. It is due to steric hindrance of bulky aryl groups. Okay, yes. Next question. Formaldehyde or benzaldehyde undergoes Carinzaro reaction. Formaldehyde, okay, this is your benzaldehyde, and formaldehyde, okay, undergoes Carinzaro's reaction. Why it undergoes Carinzaro reaction? Yes, any idea? Your formaldehyde and your this, okay, formaldehyde and your benzaldehyde, they undergo Carinzaro reaction. So first understand what is Carinzaro reaction. So whenever any aldehyde, okay, if they do not contain a alpha hydrogen means what? Besides the carbonyl carbon, when you have a carbon attached, okay, so that carbon, okay, we should have a alpha hydrogen. Now here there is no alpha carbon, right? So when an aldehyde which do not contain alpha hydrogen, okay, they react with the alkali and it undergoes self oxidation and reduction, and it gives you alcohol and a carboxylic acid salt. Okay, this is the Carinzaro's reaction. So formaldehyde and benzaldehyde undergoes Carinzaro's reaction. The reason is, okay, it has alpha hydrogen atom. Okay, it does not contain alpha hydrogen atom. Okay, it does not contain alpha hydrogen atom. Got it? Okay, so formaldehyde or benzaldehyde, it undergoes Carinzaro reaction because it does not contain alpha hydrogen atom. Okay, yes. So any question, okay, 1 mark. So each question is here for 1 mark. So it can be asked in any form. So like this, give reason form. Okay. Next question. Acetaldehyde does not undergo Carinzaro reaction. Okay. But ethanol, okay, it undergoes aldol condensation reaction. Okay. Acetaldehyde, your acetaldehyde, okay, it does not undergo Carinzaro reaction, but ethanol, okay, ethanol, it undergoes aldol condensation reaction, but this undergoes this. Why? What is the reason? Why it does not undergoes? Because it has alpha hydrogen, right? It has a alpha hydrogen. So because it contains a alpha hydrogen, okay, it will not what? It will not undergo Karen-Zaro reaction, and but it will go aldol condensation. Okay, the reason is it has alpha hydrogen atom. Okay, fine. Next question, fourth question. Alpha hydrogen atoms of aldehyde and ketones are acidic. Alpha hydrogen atoms of aldehydes and ketones are acidic. Okay, so if I consider this, so the alpha hydrogens, okay, this is the alpha hydrogen. So this alpha hydrogen, okay, of the aldehydes and ketones, they are acidic. Why? What is the reason? It is due to the strong electron withdrawing effect of the carbonyl group. Okay, because of the strong electron withdrawing effect of the carbonyl group and resonance stabilization of the conjugate base. Okay, so this is the reason, okay, why alpha hydrogen atoms are mostly acidic, because it is due to the strong electron withdrawing effect of the carbonyl. Okay, yes. Next question. Benzoic acid does not undergo Friedel-Crafts reaction. Why benzoic acid does not undergo Friedel-Crafts reaction? Yes, Friedel-Crafts reaction. Why benzoic acid? So this is a benzoic acid. Okay, this is a benzoic acid. Why this benzoic acid does not undergo Friedel-Crafts reaction? This is a carboxylic group, right? So this carboxyl group, it is a deactivating. Okay, it is a deactivating, and for a Friedel-Crafts reaction, we use what? We use the Lewis acids like the aluminium chloride, right? AlCl3. What happens when we are using as carboxyl acid is a deactivating, and the catalyst AlCl3, okay, it will get go on, it gets at bonded to the carboxyl group. Okay, it will go and get bonded to the carboxyl group. So this is the reason why benzoic acid does not undergo Friedel-Crafts reaction. I hope the answers are you have got. Okay, so here any question in the form of give reason can be asked for 1 mark. Okay. Fine. Let us move further. Next question. Explain Rosenmund reduction. Explain Rosenmund reduction. Okay. Give one example. Okay. They may ask you, give one example. So explain Rosenmund reaction. Give one example. So 2 mark question. Okay. This is a 2 mark question. This is a 2 mark question. Explain Rosenmund reduction. Give one example. So how you will going to answer? Okay. So how you are going to answer? So when they ask you, this is general question, right? Explain Rosenmund reduction. Give one example. So you are going to answer. So here, what we are doing? We are taking acid chlorides. Okay. RCOCl. Okay. Acid chlorides. So acid chlorides, okay. We are doing hydrogenation, okay. Hydrogenation by using palladium as a catalyst over barium sulfate, and we are going to get a aldehyde. Okay, we are going to get a aldehyde and HCl. So what we are doing? Acid chloride is hydrogenated. Okay, acid chloride is hydrogenated over palladium on barium sulfate to give aldehyde. Okay, and this reaction is called as Rosenmund reduction. Okay, this reaction is called as the Rosenmund reaction. So this is the general equation. Okay, this is the general equation. Now they have asked you one example. So you need to give explanation, give the general equation, and now give the example. So what I'll do, instead of R, I'm going to take CH3. Okay, so what it will be, CH3, C double bond O, Cl, in the presence of, we are doing hydrogenation in the presence of palladium and barium sulfate. What we are going to get? Acetaldehyde. Okay, I'm going to get a acetaldehyde. Okay, so this is Rosenmund reduction. So again, one time I'll repeat. Acid chloride is hydrogenated over palladium on barium sulfate to give aldehyde. Okay, this reaction is called as Rosenmund reduction. Okay, Rosenmund reduction. So given, so first give the general reaction. Okay, this is the general reaction, and then give the example. Then give the example. Okay, got it? Fine. Next question. So, or it can be asked, or how benzoyl chloride is converted to benzaldehyde. Write equation and name the reaction. How benzoyl chloride is converted to this. Okay. So if I give, so benzoyl chloride is what? So this is benzoyl chloride. Okay. In the so what we are doing, hydrogenation using palladium on barium sulfate. What I'm going to get? I'm going to get a benzaldehyde. I'm going to get a benzaldehyde. Okay. So what? So I have written the reaction. So what happens here? Benzoyl chloride is hydrogenated. Okay, is hydrogenated over palladium on barium sulfate and gives benzaldehyde. Okay, and so here so what is the name of the reaction? So this reaction is called as the Rosenmund reduction. Okay, it is a Rosenmund reduction. Like this, the question will be asked. Okay, so either directly or indirectly. Okay, so 2 mark question. Very, very important 2 mark question. So all the name reactions are very important. Okay, important question for 2 marks. So either they will ask you a general question, okay, or they will ask you indirectly. Okay, fine. Let us go for the next one. Explain stiffened reaction. Give one example. Explain stiffened reaction. Give one example. Okay. So in stiffened reaction, what we are doing? We are taking nitriles. Okay. We are taking nitriles. Nitriles are nothing but CN bond, right? So nitriles, what we are doing? Nitriles, we are doing reduction. Okay. We are doing reduction. Okay. By using what? By using stannous chloride. By using stannous chloride. Okay. With hydrochloric acid, with hydrochloric acid. So what we are doing? We are taking nitriles. Okay, we are doing reduction with what? With stannous chloride and HCl. What it gives you? It gives you a imine. Okay, it gives you imine. Okay, CH double bond NH. So this is a imine system. This is a imine system. This imine, further, what will happen to imine? I'm going to do further hydrolysis, acid hydrolysis, and I'm going to get a aldehyde, CHO plus NH3. Okay, so this is a stiffened reaction. So what we are doing in stiffened reaction, nitriles, we are doing reduction with stannous chloride and hydrochloric acid. First, it gives you imines, okay, and this imine on further hydrolysis will give you aldehyde, okay, will give you aldehyde. So nitriles, okay, on reduction will give you imines. Imines on hydrolysis further will give you aldehyde. Okay, let us give an example. Take one example now. Example, I'll take propane nitrol. So CH3, CH2, C triple bond N, right? Propane nitrile. Okay, what I'm going to do? I'm going to do reduction in the presence of that is tin stannous chloride plus HCl. What I'm going to get? I'm going to get CH3, CH2, CH double bond NH. Okay, this on further acid hydrolysis, I'm going to get CH3, CH2, CH2 plus NH3. I'm going to get a propanol. Okay, I'm going to get what? Propanol, Al. Okay, so this is the stiffened reaction. Again, a 2 mark question, very, very important. All the name reactions are very important. Okay, all the name reactions are important. So please practice the name reaction. What you have to practice in name reaction? first general, you have to explain it in the simple way, okay, how the reaction is occurring. Explanation is there. One, then general reaction you have to write, and you have to give the one example. Okay, one example. I hope you have got it. Okay, so explain Stephen reaction. Give an example. So nitriles on reduction with stannous chloride in the presence of hydrochloric acid will give you imine, which on hydrolysis will give you what? Will give you aldehyde. Okay, so like this explanation. Then one general equation. So this is the general equation. Okay, general reaction. And this is the example. I hope you have got it. Okay, so we have completed Rosenmud and Stiffen. Next is Ithard reaction. Next is Ithard reaction. So in Ithard reaction, what we are doing? We are taking toluene. Okay, we are taking toluene. We are taking toluene. Toluene means methyl substituted benzene. Okay, toluene. So toluene is reacted with chromyl chloride. Okay, it is reacted with what? Chromyl chloride in the presence of carbon disulfide. Okay, so in the presence of carbon disulfide, it will give you a chromium complex. Okay, it will give you what? It will give you a chromium complex. Okay, it will give you a chromium complex. This chromium complex on further hydrolysis will give you what? Benzaldehyde. Will give you what? Will give you a benzaldehyde. Got it? So toluene, okay, toluene in the, so when you react it with chromyl chloride, okay, when you react it with chromyl chloride, I'm going to get a chromium complex. Okay, I'm going to get a chromium complex. This chromium complex on acid hydrolysis will give you benzaldehyde. Okay, will give you benzaldehyde. Got it? So, toluene reacts with chromyl chloride in the presence of carbon disulfide to give you a chromium complex, which on hydrolysis gives you benzaldehyde. This is Ithard reaction. This is Ithard reaction. So, either like this they will ask you, or they will ask you, how do you prepare benzaldehyde from toluene by Ithard reaction? Give right equation. Like this they can ask. So this is asked directly in a twisted manner with example. How they'll ask, how do you prepare benzaldehyde from toluene by using Ithard reaction? Right equation. So again a 2-mark question. Again a 2-mark question. So all the name reactions are very, very, very important. Okay. Next question. Write equation for Gattermann-Koch reaction to convert benzene to benzaldehyde. So write the equation for Gattermann-Koch reaction, okay, to convert benzene to benzaldehyde. Okay, so how we are going to write the equation? So the equation is like benzene. Okay, benzene is there. The Gattermann-Koch, the reagents are carbon monoxide plus HCl. Okay, carbon monoxide HCl in the presence of anhydrous AlCl3, okay, or you can use cuprous chloride. What I am going to get? I am going to get a benzaldehyde. I am going to get what? Benzaldehyde. Okay, so the equation for Gattermann-Koch reaction is this. Benzene, so you have to write the names. Okay, names are very important. So benzene, and this is benzaldehyde. Benzaldehyde. Got it? Okay, so in the presence of carbon monoxide plus HCl, okay, in anhydrous AlCl3 bar cuprous chloride, I am going to get a benzaldehyde. Okay, so or they may ask you like this, or they may give you like this. They will ask you what is X. What is X? Okay, so what is X? They will ask you. So what you have to tell? The X is what? X is your benzaldehyde. Okay, X is benzaldehyde. Name the reaction. Which will be the name of the reaction if they give you this equation? Okay, if they give you this equation, if they give you first question, they'll ask you what is X. X is benzaldehyde. Okay, X is benzaldehyde. Next question they have asked is name the reaction. What is the name of the reaction? It is Gattermann-Koch reaction. It is Gattermann-Koch reaction. Okay, then so like this they will ask you. Got it? Okay. So either directly or indirectly. Fine. Next question. Ketones are generally less reactive towards nucleophilic addition reaction. Give any two reasons. So why ketones are generally less reactive? So just now we have seen when we are seeing the MCQs, so across the your double bond carbonyl group, there are alkyl or the aryl groups will be present. And so the first reason is due to steric hindrance. First reason is due to steric hindrance. That is the your alkyl or the aryl groups will be the what bulkier group. So this is the first reason due to steric hindrance of the bulky groups, due to steric hindrance of the bulky group. And the second one is the electronic effect. Second one is the electronic effect. So these are the two reasons why ketones are generally less reactive towards nucleophilic addition reaction. Okay, fine. Next question. Explain Clemenson's reduction with an example. Explain Clemenson's reduction with an example. So let us see Clemenson, very, very important. Clemenson's, okay. Aldehydes and ketones, okay. Aldehydes and ketones, they are, we are reducing them, okay. Either you take aldehyde, okay, either you take aldehyde or you take ketone. Okay, we are going to do reduction in the presence of zinc amalgam and HCl. Okay, zinc amalgam and HCl. I am going to get a alkane. I am going to get a alkane. Okay, so aldehydes and ketones on reduction with zinc amalgam and concentrated HCl. I am going to give. I am going to get hydrocarbons. I am going to get hydrocarbons. So this is the reaction. Now give you the example. Okay, general reaction. If I take propanol, both the R as your CH3. Okay, take propanol and then you do zinc amalgam and concentrated HCl. What I'm going to get? I'm going to get CH3, CH2 and CH3. I'm going to get a propane. I'm going to get what? Propane. Okay. Similarly, if I take now, instead of this, if I take aldehyde here, H. Okay, so this is what ethanol. This is our ethanol. Okay, now if I take ethanol, when you treat it with zinc amalgam and concentrate HCl, what I'm going to get? I'm going to get what I'm going to get CH3, CH3. Okay, I'm going to get ethane. I'm going to get ethane. Got it? So this is Clemenson reduction. Again, very important 2-mark question. Okay, 2-mark question. Got it? Okay. So again, the question can be asked like this. So this is directly asked. Explain Clemenson reduction with an example. They can ask you like this also. Write equation for the conversion of propanol to propane. Okay, or they may ask you write equation for the conversion of ethanol to ethane. Okay, like this. Depending on what they'll ask you. Okay, different example. Got it? Fine. Next question. What is Wolff-Kishner reduction? What is Wolff-Kishner reduction? Write the general equation. What is Wolff-Kishner reduction? Write the general equation. How you are going to answer this, students? How you are going to answer? So here the carbonyl group, okay, the carbonyl group of the aldehydes and ketones, they are reduced to hydrocarbon. They are reduced to hydrocarbon. How? They are reacted with hydrazine. They are reacted with hydrazine, okay, and followed by you are going to heat it with what? Okay, you are going to heat it with your this ethylene glycol in potassium hydroxide. Okay, ethylene glycol in potassium hydroxide. So this is when you react it with hydrazine NH2. Okay, with the removal of water molecule, what I'm going to get? I'm going to get a C double bond N NH2. This further heat it with the presence of KOH and ethylene glycol. Okay, ethylene glycol. What I'm going to get? I'm going to get this, okay, hydrocarbon. I'm going to get what? Hydrocarbon. Got it? Yes? Okay. Fine. So this is our Wolff-Kishner reduction. This is our Wolff-Kishner reduction. So you can take any aldehyde or ketone. Okay, you're going to get a hydrocarbon in the product. Fine. Next reaction. What is haloform reaction? Give one example. What is haloform reaction? Give one example. What is haloform reaction, students? What is haloform reaction? So whenever you have any aldehyde or ketone and it is containing at least one methyl group, okay, attached to the carbonyl carbon atom. So this the methyl group which is connected to carbonyl carbon atom, okay, it is treated with the sodium hypoiodide, okay, and haloform is formed. Suppose I have C double bond O CH3, okay. So this is treated with what? Sodium hypoiodide. Okay, what I'm going to get? I'm going to get a sodium salt of acid. Okay, sodium salt of acid plus CHI3. Okay, so this is CHI3. This is iodoform. This iodoform is yellow in color. Okay, this is iodoform is yellow in color. So this is the haloform reaction. This is the haloform reaction. If I take example, take RsCH3. Okay, take RsCH3. So propanol react it with what? Sodium hypoiodide. Sodium hypoiodide. What I'm going to get? I'm going to get a salt. Okay, plus CHI3. This is your iodoform. This will give you the yellow color. Okay, so what is haloform reaction? Give one example. So when aldehyde and ketones contain at least one methyl group is attached to the carbonyl carbon atom, it is treated with your sodium hypoiodide and haloform is obtained. Okay, haloform is obtained. Yes. Next question. Explain aldol condensation with an equation by taking acetaldehyde. Explain aldol condensation with an equation by taking acetaldehyde. Yes. How you will explain aldol condensation? So I will take acetaldehyde. Okay, they have told me to take acetaldehyde. So acetaldehyde CH3 C double bond O and okay, so this is our acetaldehyde. So this acetaldehyde, so one more molecule of acetaldehyde. Okay. So one more molecule of acetaldehyde. So what will happen? You have a base NaOH. So this base will abstract the proton. Okay. The base will abstract the proton. This base will abstract the proton and this carbon anion, okay, will attack the carbonyl carbon. Okay, this bond will polarize. So write it now. CH3 CO minus H CH2 CHO. Okay. Now what will happen? Okay, what will happen? Here a proton transfer will take place and here hydrogen will be added. Okay, here hydrogen will be added. So this is what? 3 1 2 3 1 2 3. So 3 hydroxy butane. So it's here. See the number of carbon atoms: 1 2 3 and 4. So 3 hydroxy butane al. Okay, so you're getting a aldol. This aldol further when you heat, okay, what will happen? What will happen? Hydrogen from here and water from here. You're going to get CH3 CH double bond CH CHO. I'm going to get a but2 al. Okay, but2 al. So what is aldol condensation? Aldehyde containing at least one alpha carbon atom, one alpha hydrogen atom. It will undergo self-condensation in the presence of a dilute alkali, that is your NaOH, to form an aldol. Okay, this aldol, what will happen? It will readily lose the water molecule to give you alpha beta unsaturated carbonyl compound. What it will give you? Alpha beta unsaturated carbonyl compound. Okay, so this is what aldol condensation. So they have asked here with an example. So you need to take acetaldehyde only. If they ask you with ketone, acetone, okay, if they ask you with acetone, then you have to explain with acetone. Okay, so explain aldol condensation. Aldehyde containing at least one alpha hydrogen atom undergoes self condensation in the presence of dilute NaOH. Okay, it forms aldol. This will readily lose water and forms alpha beta unsaturated carbonyl compound. Got it? Okay. Next, explain Carinzaro reaction with an example. Explain Carinzaro reaction with an example. So how we are going to explain Carinzaro reaction? So very, very important. Huh? So these are all questions again, 2 marks question. All are 2 mark question. Okay, 2 mark question. Fine. So we have studied seeing the Carinzaro reaction. So Carinzaro reaction is what? When aldehydes, okay, which do not contain alpha hydrogen, they will react with your concentrated alkali and it will undergo self oxidation and reduction to give you an alcohol and a salt, okay, carboxylate salt. Suppose I have formaldehyde, okay, formaldehyde does not has a alpha hydrogen, okay, so it will react with a base like your NaOH, okay, what it will give you? It will give you a alcohol and you are going to get a sodium salt of formate. Okay, so this is a sodium formate and methanol. So what you are going to get? Methanol and sodium formate. Okay, and sodium formate. So here, okay, got it. So formaldehyde, okay, your formaldehyde is reacted with your what alkali, that is NaOH. Why? Because it does not have a alpha hydrogen. So whenever aldehyde and ketones do not contain alpha hydrogen, they will react with the concentrated alkali and it undergoes a self oxidation reduction to form a alcohol and carboxylate acid salt. Okay. So again, this is a 2-mark question. Okay. And 2-mark question. Okay. So next, the questions based on carboxylic acid. Okay, these are the questions based on carboxylic acid. So 2-mark question, how carboxylic acids, okay, how carboxylic acids are prepared from Grignard reagent? How carboxylic acids are prepared from Grignard reagent, or write a general equation, or write general equation for the formation of carboxylic acid from Grignard reagent. Okay, so you have to explain how carboxylic acids are prepared from Grignard reagent or write the general equation for the formation of carboxylic acid from Grignard reagent. So Grignard reagent, how they react with your carbon dioxide. Okay, and what it does, it forms the salts of carboxylic acid. Okay, this salt of carboxylic acid, further it will go acidification and it will give you a carboxylic salt. So how? So RMgX, your Grignard reagent, will react with your carbon dioxide. Okay, it will react with your carbon dioxide in the presence of dry ether. In the presence of dry ether. So how carboxylic acids are prepared from Grignard reagent? Your Grignard reagent reacts with your carbon dioxide in the presence of dry ether, and it forms. So I'll write the product here. I'll write the product here. RC R C double bond O minus Mgx plus. Okay. Further, it will undergo hydrolysis, acid hydrolysis to give you carboxylic acid. Okay, so carboxylic acid, how they are prepared? Take Grignard reagent, react it with carbon dioxide in the presence of your dry ether. Okay, further on acidification, you will get carboxylic acid. So this is the reaction. Again, a 2-mark question. Okay, again a 2-mark question. Next, among methanoic acid and ethanoic acid, which is more acidic and why? Among methanoic acid and ethanoic acid, which is more acidic and why? So this is your methanoic acid. Okay, and this is your ethanoic acid. Okay, so which is more acidic and why? What is the reason? So methanoic acid is and ethanoic acid, which is acidic, they have asked. It is methanoic acid. Okay, methanoic acid because here you can see, okay, in methanoic acid, it is more acidic as because in ethanoic acid, okay, your CH3 group is attached to carbon atom. Okay, your this is attached to carbon atom and okay, and this is what CH3 is the electron donating group. So what will happen? It will decrease the polarity of the OH bond, right? So because of that, the acidity decreases, then the methanoic acid. So methanoic acid is more acidic in nature. Okay, methanoic acid is more, this is, if it is due to plus I effect. Okay, due to plus I effect. Plus I effect. So first reason, methanoic acid is more acidic. Reason is due to plus I effect in ethanoic acid. Okay, fine. Next question. Explain esterification reaction with an example. Okay, what is esterification reaction? When carboxylic acids, okay, when carboxylic acids are heated with your alcohol, okay, in the presence of concentrated H2SO4, okay, what you are going to get? I'm going to get a ester. Okay, I'm going to get a ester plus water. Okay, so this is the your esterification reaction. Esters are produced. These esters are sweet smelling. They are sweet smelling. So this is the esterification reaction. So I can take CH3 COH plus I can take C2H5 ethanol in the presence of concentrated H2SO4. What I am going to get? CH3 C double bond O C2H5 ethyl methyl ester. Okay, plus water. Okay, so this is your compound. So this is a ethyl acetate. Okay, this is a ethyl acetate. Ethyl acetate is obtained. Got it? So this is esterification reaction. Again, a 2-mark question. Next question. Explain HVZ reaction with an example. Explain HVZ, Hell-Wohlhard-Zelinsky reaction with an example. How you are going to explain? So, RCH2 COOH, okay, in the presence of X2 and red phosphorus followed by hydrolysis will give you RCH COH and X. This is a alpha halocarboxylic acid. Alpha halocarboxylic acid. Okay, alpha halocarboxylic acid. So what is Hell-Wohlhard-Zelinsky reaction? Carboxylic acid having an alpha hydrogen. Okay, it is treated with your chlorine or bromine in the presence of red phosphorus. Okay, it will give you what? It will give you a alpha halocarboxylic acid, and this reaction is called as the Hell-Wohlhard-Zelinsky reaction. Okay, it is called as the Hell-Wohlhard-Zelinsky reaction. Okay, Hell-Wohlhard-Zelinsky, that is called as HVZ. Okay, carboxylic acid having an alpha hydrogen on treatment, okay, with the chlorine or bromine in the presence of red phosphorus gives you alpha halocarboxylic acid. This is known as the Hell-Wohlhard-Zelinsky reaction. Got it? So you get the alpha halocarboxylic acid. Okay, so let me give an example. So I will take RSCH3. Let me take the RSCH3. Okay, so if I take this as CH3, what I'm going to get? So I'm going to get CH3 COOH. Okay, on treatment with chlorine in the presence of red phosphorus. What I'm going to get? I'm going to get one of the hydrogen will be replaced by chlorine and COOH. Okay, I'm going to get a monochloroethanoic acid. Monochloroethanoic acid. Got it? Yes. So this is your Hell-Wohlhard. So this is acetic acid. This is acetic acid. You reacted with chlorine in the presence of red phosphorus to give you monochloroethanoic acid. Got it? Okay. Last question. What is action of ammonia on benzoic acid? What is the action of ammonia on benzoic acid? So take benzoic acid. Take benzoic acid. React it with ammonia. Okay, so what will happen? Your hydrogen will be replaced by the ammonium salt. So you are going to get a ammonium benzoate. I'm going to get what? Ammonium benzoate. I'm going to get ammonium benzoate. So this ammonium benzoate, again, further you are going to heat it. You are going to heat it. I'm going to get what? After heating, I'm going to get the amide. Okay, I'm going to get what? I'm going to get the amide. And this is a benzamide. This is what? Benzamide. I have started with benzoic acid. So benzoic acid is heated with ammonia to give you ammonium benzoate. Ammonium benzoate. This ammonium benzoate, I'm heating okay, to give you benzamide, okay, to give you benzamide. Got it? Yes, is it clear? Okay, so these are the questions from the your 2 marks. Okay, so next is a 3 mark question. Okay, 3 mark question. One question is there. So let us see the 3 mark one question. Explain the mechanism of addition of hydrogen cyanide to aldehyde in the presence of NaOH. Okay. Explain the mechanism of addition of hydrogen cyanide to aldehyde in the presence of NaOH. So first step, I'll write stepwise. First step is formation of nucleophile. Okay, formation of nucleophile. First step is formation of nucleophile. Okay, so first is your hydrogen cyanide reacts with the base. Okay, reacts with the base, and you are going to get Cn minus plus H2O. Okay, you are going to get Cn minus plus H2O. So this is the first step. This is the step 1. Okay, formation of nucleophile. Formation of nucleophile. Okay, hydrogen cyanide reacts with the base, that is your NaOH, to give you Cn minus and water. Okay, so this is the first step. They are explaining the mechanism. Okay, then second step is the nucleophile. The nucleophile. So which is our nucleophile? Cn minus. Okay, Cn minus. It attacks the carbonyl group. Attacks the carbonyl group of aldehyde or ketone. Aldehyde or ketone to form tetrahedral tetrahedral intermediate. So let us see the second step. So this is our carbonyl carbon. Okay, this is your carbonyl carbon group. So your Cn minus will attack. Okay, this will attack to the carbonyl carbon. This will get polarized. What you are going to get? CO minus. Okay, your Cn will attach. So this is the compound. This is the compound. Got it? So this is the tetrahedral intermediate. This is a tetrahedral intermediate. Then step 3. Step 3 is what? Formation of cyanohydrine. Formation of cyanohydrine. Formation of cyanohydrine. Okay. So what is the next step? So CO minus. Okay. Then Cn. Then plus H plus. Okay. H plus. So what you are going to get? OH and Cn. So this is the cyanohydrine. Okay. So explain mechanism of addition of hydrogen cyanide to aldehyde in the presence of NaOH. First step, formation of nucleophile. Okay. You're reacting your hydrogen cyanide with your OH minus. You are going to get Cn minus. Okay. Base will attack the hydrogen cyanide and you are going to get cyanide ion plus water molecule. So nucleophile is generated. Then the nucleophile, that is cyanide ion, will attack the carbonyl group, okay, of the aldehyde or ketone, and it will form a tetrahedral intermediate. So here you can see the attack I have shown. So this is the cyanide ion. It will attack the carbonyl carbon. This bond will get polarized. So this is the form. So O minus, okay, and Cn will be getting attached here. So this is the intermediate. Then formation of cyanohydrine. So here your OH minus, so it will take up the proton and it will form the cyanohydride. Understood? Okay. So these are the questions. Okay. So these were some of the questions from the chapter aldehyde, ketones and carboxylic acid. So as we have discussed in our previous sessions also, that this particular chapter from chemistry, aldehyde, ketones and carboxylic acid is for 14 marks. So we have seen the 1 mark question, okay, and we have seen that is the MCQ question. Then we have seen 2 mark question, 3 mark question, okay. So as you know, 5 mark question is not directly asked, so it can be asked. Your 5 mark question, we have covered 2 plus 2 plus 1 also, and we have covered 2 plus 3 mark also, okay. So all the questions are covered. Is it clear? I hope there are no doubts. Okay. So, these are also all the name reactions are very important. So don't leave any name reactions. Okay. So practice with the this what general reaction also, as well as one example each. Okay. Very, very important. So whenever you are writing any name reaction, or when you are writing the organic reactions, you need to write the name of the structures. Okay, write the name of the structures, or write the explanation properly, write the structures properly. Okay, so don't do mistakes in writing the structures. So if the structures are wrong, then everything will be wrong. Okay, so write the structures. So practice these name reactions. So you cannot bahar these name reactions. Okay, so for that, practice is very important. So as you so how much you'll practice, okay, so that much perfect you'll be. So yes, so by this I hope you have understood today's session also. So yes, so I shall end this session here. Thank you.